The Acme company manufactures widgets. The distribution of widget weights is bell-shaped. The widget weights have a mean of 54 ounces and a standard deviation of 11 ounces. So this bell-shaped thing is a keyword. Bell-shaped means that we can draw it like this, and that means a whole lot about the distribution of the data. We're going to use the standard deviation rule, known as the empirical rule is what I call it in the notes, to solve this problem. Before I even read these questions, I'm going to go ahead and start drawing the empirical rule. So we need a horizontal line and then a vertical line coming up in the middle of it. And then draw a bell-shaped. It doesn't matter how pretty it is. And then we're going to draw a line down the center of the curve. And we need 3 lines to either side. So 1, 2, 3. And then 1, 2, 3 on the other side. I like to shade mine in. It's optional. So the center 2 is 68%. So I'm going to shade that in and label it 68%, or there's 34% on this side and 34% on this side. How do I know that? It's just a rule, like a definition. There's a bunch of math and calculus that's behind it to back it up, but for our purposes, we're just going to go with it. All right, so the next sides out from the middle are going to be shaded teal, and these are 13.5% each. And then I'll shade the next sections orange. And I'm shading them the same color because they're going to be the same percentage. This one is 2.35%. And then lastly, there's a little tiny bit at the end. It's tinier than what I've drawn here. And I'll color that in pink. All right, and those are 0.15% each. And that accounts for all of it. If you add up all of those percentages, it would equal 100%. All right, now I'm ready to actually look at the problem. Going back to the top, it says that we have a mean of 54, standard deviation of 11. So that's important, we need that. The mean is gonna go in the center, and then was 11, okay. It's gonna be 11 plus 11 and minus 11 on either side of that to get to the next number. So 54 plus 11 is 65, plus another 11 is 76, and then 87. So just 3 numbers labeled on each side. Minus 11's 43, then 32, then 21. And the numbers should match up with the questions that they give you. So you see that in part B, they give you 32 and 87, and I have those on my graph. So I've probably labeled my numbers correctly. And we also got 43, which is right here. All right, first question is 99.7% of the widgets lie between which 2 numbers? So I didn't put it on here because it's not always useful, but 99.7 would be from here. And then I'm just gonna style. I'm gonna make this dotted to here. So essentially, if you wanna think of it more technically, we're 3 standard deviations away from the mean. So this area here that I have sectioned off is 99.7% of the data. And since we're labeling that one, I'll go ahead and tell you that from here, like 2 standard deviations away from the mean is 95% of the data. All right, and then the middle two I've already said are 68. So those three numbers, 68%, 95%, and 99.7% are representing this is 1 standard deviation away, 2 standard deviations away, and 3 standard deviations away. It's not so important that you know that. It's more important that you can draw, shade, and label all the little pieces of the curve. All right, so going back to the question, I know I'm maybe getting a little bit more in depth than you wanted me to, but I want to make sure that it all makes sense. All right, so from the 99%, 99.7%, we would get 21 and 87. So I've drawn that in pink. That's where 99.7% of the data lies. So we're going to put 21 and 87 here. What percent of the widget weights lie between 32 and 87? So this one we just need to add it up. So 32 is right here, 87 is here. So those percentages are 13.5. So I'm going to do everything between those, right? And I'll just shade that or draw that out in these pink stripes. That's the area that I'm going to add up. So 13.5 plus 34 plus 34 plus another 13.5, and then there's a plus 2.35%. So we're going to add all that together, and so that would be the same as 99.7 minus 2.35. Ignore that I said that. There's more than one way to get these answers, right? You can use some subtraction as well to get them. 97.35%. All right, and then the last one, what percentage of the widget weights lie above 43? So we're gonna find 43. I'll grab another color, maybe this bright blue. Here's 43. So we want all the area that I'm drawing blue lines in. So that's gonna be 34% plus 34%. Plus 13.5%, plus 2.35%, and plus 0.5%. Another way of thinking of it is it's everything except for these three on the other side of it. So that is another way to get the answer, but you know, just do whatever makes sense to you. All right, I'm going to add this up. 13.5 plus 2.35. Plus 1.5, 84. All right, now before I end the video, I'm going to make sure that the answers are all correct. And oh, that's a different problem. All right, let me get to this one. 21 and 87, 97. I should have done this ahead of time. Oh yeah, I forgot to write that in. So This last one is 84%. And you don't actually write the percentages because those are given to you. But yeah, I hope that helps. Just as a recap, if you're given a empirical rule problem, then draw it out, shade, fill in all the percentages, and then worry about what the problem says.